Hello, this is Dr. Hanaa Assil, and this is Unit 2, January 2021 paper in the IAS Chemistry Edexcel. Let us take a look at the questions and discuss the answers. So the first section, of course, is multiple choice questions, and this question has energy profile for a reaction. And he's asking what is the minimum energy needed for this reaction. Remember, the minimum energy needed for a reaction to occur, that is activation energy. Now, where is activation energy in the energy profile diagram? You should realize that activation energy is the difference in energy from reactants to the top. So in this case, activation energy is X. So my answer is A. Which of these isomers with the formula C8H18 has the lowest boiling temperature? Again, what determines the lowest boiling temperature? Remember we said, first of all, the number of carbons. The one with more carbons has higher boiling point. But here he's telling me all of them have the same number of carbons. So in that case, the one with more branching is the one that has lower boiling temperature. So in order to find which of these is the lowest boiling temperature or has the lowest boiling temperature, you are looking for which one has more branching. So in order to do that, you either imagine what this looks like or draw it out. I prefer to draw it out. So this is the structure in A. So this is what we call 2,5-dimethyl hexane. This is structure B if you try to draw it. This is structure C, and this is structure D. Now, which of these has more branching? You can see that structure C is the one that has more branching. So this would be the one that has lowest boiling temperature. If he's looking for which one has the highest boiling temperature, it would be structure D, because this is the one that is a straight chain. A straight chain will have higher boiling point than a branched chain. Which of these pure compounds has hydrogen bonding in the liquid state? I'm going to remind you that in order to have hydrogen bonding, it should have hydrogen bonded to an electronegative element. So let us take a look at each of these. So structure A is this one. We do not have hydrogen bonded to an electronegative element. We do not regard carbon as electronegative. And the electronegative element which we have, which is chlorine, is not bonded to hydrogen. So this molecule would not have hydrogen bonding between its molecules. Trimethylamine. Also, we don't have a hydrogen bonded to an electronegative element. But in HF, you can see that fluorine is a very electronegative element. I have hydrogen attached to fluorine. So these molecules will have hydrogen bonding between them. H2S, sulfur is regarded as a very low electronegativity, so this will not form hydrogen bonding. So the one that forms hydrogen bonding is HF. The hydrogen ion, H plus, bonds to a water molecule forming an H3O plus. The hydronium ion, how do we draw a hydronium ion? Remember that H2O is just oxygen bonded to two hydrogens. But when the lone pair of electrons on the oxygen are used to make a bond with an H plus, then we have this kind of structure. This is the structure of the hydronium ion. Now, what is the shape and the bond angle of this? Remember that we said this is something in which the oxygen has now one lone pair of electrons. It is repelling three bonding pairs of electrons. This kind of structure is called trigonal pyramidal, and its bond angle is 107. Viscosities of 4 liquid organic compounds are compared by placing the liquids in separate identical tubes, each with an air bubble at the top. The tubes are inverted and the times measured for the air bubble to travel the length of the tube. For which compound does the air bubble take the longest time? Remember, if it takes the longest time, that means that the liquid is more viscous. Now, the liquid will be more viscous if it has more hydrogen bonding between its molecules. So the question is, which of these has more hydrogen bonds between its molecules? So if we look at A, each molecule will form one hydrogen bond with the next molecule. In B, we have two OH groups, so we have two hydrogen bonds per molecule. In C, we're going to have three hydrogen bonds per molecule. In D, there are no hydrogen bonds at all. So C is the one that will form more hydrogen bonds. So this would be the higher viscosity, and that means the air bubble will take the longest time. This question is about the reaction of potassium iodide with concentrated sulfuric acid. Remember, we said potassium halides or sodium halides with concentrated sulfuric acid. What happens when we have iodide? We said the iodide with the sulfuric acid forms HI, and HI is a strong reducing agent, so it will go back and react with the sulfuric acid and reduce it. So in that case, we can form misty fumes are the HI, so these we can form. Black solid, that would be the iodine if we have it in the form of solid. Yellow solid is the sulfur. We have sulfur forming. We also have sulfur dioxide gas forming, but we will not have, he's saying which of these would not be seen. We will not see dense white smoke. It will not form dense white smoke. One of the reaction products is the gas H2S. What is the change in oxidation number? Now, this is a sort of tricky question. He's not saying what is the new oxidation number of sulfur in H2S, what is the original oxidation number. He's saying what is the change in oxidation number. We were changing from H2SO4 to H2S. Now, if you calculate the oxidation number of sulfur in H2S, it is -2. If you calculate it in H2SO4, it is +6. So we started with sulfuric acid, in which the sulfur has oxidation number +6. We ended up with H2S, in which the sulfur has an oxidation number of -2. So what is the change? Going from +6 to -2, that is a change of -8. Okay? Here he's saying iodate ions oxidize these ions according to the equation. He has an ionic equation and he's telling you to balance it. So let us take a look at this. This balancing of this equation is a little bit lengthy. It takes some time. Let's take a look at the beginning. The iodine, before the arrow I have 1, after the arrow I have 2 iodine atoms, so I need to put 2 in front of the IO3. Then we look at the sulfur. Before the arrow I have 2 sulfur, so after the arrow I should put 2 sulfur. Now the hydrogens also, before the arrow are 8, after the arrow is 8, so that is balanced. Now we need to look at the oxygens. And the problem is we need to balance the atoms and we need to balance the charges. So looking at the oxygen before the arrow, we have 6 oxygens plus another 6, that's 12, plus 4, that's 16. After the arrow, I have 2 times 4 is 8 oxygen. So I need to increase that. You will find that you will need to increase it until we reach 2, 5, and 10. That is when you will have all the atoms and the charges balanced. Magnesium reacts with hydrochloric acid. Which statement about this reaction is correct? So he's asking which one is oxidizing and which one is reducing. So let us take a look at this equation. Now the oxidation number of magnesium is 0 at the beginning. It changes to +2. That is oxidation. So the magnesium is oxidized, and that means it acts as reducing agent. Remember, the reducing agent is the one that was oxidized. and the oxidizing agent is the one that was reduced. So the magnesium was oxidized, so it is acting as reducing agent. So A is wrong. Then let us take a look at the hydrogen. In HCl, the hydrogen has an oxidation number of +1. Now it changes to H2, in which the oxidation number is 0. From +1 to 0, that is reduction. So the hydrogen was reduced, the H+ ions were reduced, and that means they are acting as an oxidizing agent. So C is the one that is correct. Of course, the chloride has, it is starting before the arrow with oxidation number -1, and it is ending after the arrow also with oxidation number -1. So actually the chloride ions were neither oxidized nor reduced, so D is wrong. Okay, question 9 says, which of these compounds does not produce a color in flame test? So if it does not produce a color in flame test, then it is not calcium, for example. It produces an alkaline gas when warmed with sodium hydroxide. This is a test for what? When we say we add sodium hydroxide and warm gently and we get a gas that turns damp red litmus paper to blue, that means I have ammonium. So it must be ammonium, which is choice C. Which of these increases as group 7 is descending? So going down group 7, which of these is increasing? I'm going to remind you that going down group 7, we said if we look at group 7, the fluorine has the smallest atomic radius, so it is more reactive as an oxidizing agent and it is less reactive as a reducing agent. As we go down, what is increasing as we go down the group is the reducing ability, the ability to reduce. So actually, the reducing ability of the halides, that is choice B, is the one that is increasing as we go down. Otherwise, the radius also is increasing, of course. The reactivity will be decreasing as we go down. This question says the table shows the amount of energy released per gram when some alkanes are burned in excess oxygen under standard conditions. So he gives the table of the energy released in kilojoule per gram for each of these, and he's saying which alkane has a standard enthalpy change of combustion of this number in kilojoule per mole. So we need to change the kilojoule per gram to kilojoule per mole. That means for each of them, we need to calculate the number of moles. That would be mass over molecular mass. He's giving me this number per gram. That means my mass is 1 gram. Now that means I have this number of moles. Then I use the value from the table to calculate delta H, because delta H is Q over N. So it is the number from the table over the number of moles that we calculated. So we're going to do this for methane, ethane, propane, and butane, and we find that it is the one for butane that gives the number he is looking for, -2877 kilojoule per mole. The enthalpy changes for two reactions are shown. What is the enthalpy change for the dissociation of CH3COOH into CH3COO- and H+? So this is obviously using Hess's law. So he wants this equation on top, CH3COOH, to give CH3COO- plus H+. So that is the delta H we're looking for. Now, the information that he gives me is if I react the H+ with OH- and the ethanoic acid with the OH-. So these products in the box below are the common products for both of them. And we use the values from the information that he gives me in order to get the delta H that I want. So looking at the arrows, you can realize that the delta H that I want plus the value that he gives, 57.2, will be equal to the other value, which is -56.2. 0. So that means that delta H minus 57.2 is equal to minus 56. And I can solve for delta H, and that comes out to be plus 1.2. What is the skeletal formula of 2-chloro-4,4-dimethylhexane? So, which of these is this compound? Hexane means I have the longest chain is 6 carbons. Of course, D is not the correct answer. Then I want chlorine on carbon number 2, and on carbon number 4 I need 2 methyls, so that is obviously the structure in B. Some alcohols react with concentrated phosphoric acid to form alkenes. So you know that when we have an alcohol, if I add concentrated phosphoric acid, it removes H and OH and it changes it into an alkene. What type of reaction is this? When we remove something, this is elimination reaction. The structure of 2-methyl-pentane-thiol is shown. This alcohol reacts with concentrated phosphoric acid. How many different alkenes can be formed? Well, let's see. Alkenes are formed if you remove H from one carbon and OH from the neighboring carbon. So I can have the H that I'm removing from the left or from the right. So these are two options that I can have. Now let us look at each of these. Can I have any isomers of this? You know that if I have a double bond, then I could possibly have a cis and trans. So looking at this first double bond, well, it does have different groups on both carbons that are on both ends of the double bond. So I can have a cis and trans isomer for that. But the one below, it has similar groups on the same carbon. So that carbon on the end has 2 methyl groups. So this will not show a cis trans. So I have only these 3 isomers. So I have a total of 3 isomers. The next question says magnesium nitrate decomposes on heating. What is the total volume of gas formed at room temperature and pressure when 0.005 mole of magnesium nitrate decomposes completely? Now, this is the equation, and we have 2 moles of magnesium nitrate form how many total number of moles of gases? Remember, which ones are the gases? NO2 is a gas, O2 is a gas, it will form 2 moles of magnesium nitrate will form 4 moles of NO2 and 1 mole of O2, so it forms 5 moles of gas. Remember, he's saying the total volume of gas. So that means that the 0.005 mole that he gives me would form how much? It would form 0.0125 moles. And that means what would be the volume of that? The volume is number of moles times 24. We want it in centimeter cubed, so multiply that by 1,000. So your answer is 300 centimeter cubed. How many moles are there in 15.1 centimeter cubed of liquid propanol? Now he gives me the density and the MR, and he wants to know how many moles. You know that density is mass over volume, so that means that mass is density times volume. He gives me the density as 0.8 times the volume 15.1. This is in centimeter cube. That is okay because the density is given in gram per centimeter cube. So that means that the mass I have is 12.08 grams. Now he wants the number of moles. Number of moles is the mass over the molecular mass. So that means if you look at the choices, he's not giving me a final answer. He's giving me how did we get the answer. So what did we do? We multiplied the density by the volume, and then we divided by the MR, so my answer is A. The oxidation of propanol by acidified potassium dichromate forms propanoic acid with a yield of 36% by mass. And he's saying what mass of propanol do we need to form 37 grams of propanoic acid, keeping in mind that this 37 grams is actually only 36% of what I should get. So this is my equation. I'm starting with propane 1-ol, and I'm oxidizing it with acidified potassium dichromate. This gives propanoic acid. Now we're saying what is the mass of propanol that is needed to form 37 grams of the acid. And he's saying this 37 grams is 36% by mass. So if the 37 grams is actually only 36%, so what would be the 100%? Can you see these ratios with respect to math? So the yield, if we have 100%, the yield should be 102.8. The fact that he got 37 grams, that is because he got only 36% of what he should get. So what he should get is 102.8. And that means what should we start with? The number of moles of the propanoic acid is mass over molecular mass. So the number of moles of the acid is 1.39 mole. Now, looking at the equation, 1 mole gives 1 mole. So this is the same as the number of moles of propanol. Now get the mass from the number of moles. The mass is number of moles times mR. And that means that I will need to start with 83.3 grams of propanol. Is that okay so far? Okay. Barium chloride solution reacts with gallium sulfate solution to form precipitate of barium sulfate. Now, what is the minimum volume of 0.1 mole per decimeter cubed of barium chloride that is needed to precipitate all the sulfate ions in 200 centimeter cubed of 0.05 mole per decimeter cubed? So let us take a look at this. What is the equation that we have? So this is the equation. He's reacting barium chloride with gallium sulfate. Of course, this gives barium sulfate plus gallium chloride. And then we balance it. So you will find that you will need to balance it like this. Then we see what is he giving me information about. He's giving me information about gallium sulfate. So I have to get the number of moles of gallium sulfate. This is concentration times volume. Again, remember the volume has to be divided by 1,000 to change it to decimeter cubed. And that means we have 0.01 mole of gallium sulfate. Then we look at the equation and we relate it to the barium chloride. So from the equation, the number of moles of barium chloride should be 3 times the number of moles of gallium sulfate. Now we have the number of moles, then we can calculate the volume. The volume is number of moles over concentration. So that gives me 0.3 decimeter cubed. You multiply by 1,000 because the choices are in centimeter cubed. So my answer is C. Then we go into the second section. The second section is questions with short answers. Ethanol can be made in industry by the reaction of ethene with steam using phosphoric acid catalyst. So he's reacting ethene with steam to give ethanol, and he's saying the reaction is carried out at 300 degrees Celsius and 60 atm. And he says an initial yield of 5% is achieved when the ethene and steam first pass through the reactor. Now, explain the chemical reasons for the conditions used and why such a low initial yield is acceptable in the industrial process. So let us look at the equation. The forward reaction is exothermic. This is because the delta H is negative, of course, and that means if I want more ethanol to be formed, I need to use a lower temperature. So why do we use 300 degrees Celsius? You should realize that this is low enough so that it can favor the forward reaction. It's not too high, but at the same time, I cannot go too low because temperatures that are too low will cause the rate to be too slow. So the choice of the temperature is it should be Not too high so that it does not favor the backward reaction, and not too low so that the rate is very slow. Now, what about the pressure? We're using a pressure of 60 atm. That means I'm increasing the pressure. Remember that increasing the pressure causes the equilibrium to shift to the side that has less number of moles. And in this case, going forward would have less number of moles. So if I increase the pressure, that means the equilibrium will shift to the right. It will give more ethanol, so that will be a higher yield of ethanol. But I shouldn't use a pressure that is too high, because higher pressure requires special equipment that would be too expensive. So 60 atm is a good choice. Now, he says we use phosphoric acid catalyst. Remember that the catalyst increases the rate of the reaction. It provides an alternative pathway with lower activation energy, so that I do not need to raise the temperature in order to make my reaction faster. So the catalyst increases the rate of the reaction without being too expensive. Now, he's saying it will give a low initial yield. Now, this low initial yield is okay, because anything that remains will be recycled. So if I have a low yield, I will remove the ethanol as it is being formed. So that causes the equilibrium to shift to the right and give me more product. And at the same time, I will recycle the reactants again over the catalyst so that it will be reused. Then the product of the reaction is a mixture of ethanol and water. Explain why ethanol and water mix together. Remember that we said things will dissolve in water if they're ionic, then the water will surround the ions, or if it can form hydrogen bond with water. Ethanol is something that can form hydrogen bond with water, and that is why it mixes with water. So ethanol and water have hydrogen bonded to an electronegative element, which is oxygen, and this allows it to form hydrogen bonding, and that means they will dissolve in each other, or they will be miscible. Ethanol can be oxidized using a solution of acidified potassium dichromate. Now, ethanoic acid and another organic compound are possible products. If I have ethanol and we oxidize it using a solution of acidified potassium dichromate, what are the possible products? Remember, this is a primary alcohol, so if I oxidize it, it will first form the aldehyde, and if we continue to heat it with the oxidizing agent, it eventually gives ethanoic acid, or the carboxylic acid. So he's saying it will give ethanoic acid and something else. Yes, that other thing is the aldehyde. It will form ethanol. State the conditions needed to maximize the yield of each product. So he's saying conditions of maximum yield of Y. Y was the aldehyde. So how do I get the aldehyde? If I remove it as it is being formed using simple distillation. So if I do the oxidation reaction in the flask and connect that to the condenser and do simple distillation, then the ethanol as it is being formed, it will be removed, and that will give me the aldehyde. But if we want the acid, we need to do what? We need to heat under reflux. Heat under reflux means I put the condenser vertically on the flask and I keep heating this. Whatever evaporates will cool and come down, so that we do not lose the alcohol or the acid. Heating under reflux changes the alcohol into acid. Compound DMAA was originally synthesized as a decongestant. A suggested synthetic route for this compound is shown, and he's saying give the systematic name of compound A. How do we get the systematic name of any organic compound? We said the first thing we need to do is choose the longest chain. So let us see, where is the longest chain of compound A? So this is something that has 6 carbons, so it is hex something. It has an OH, so it is an alcohol, and the OH is on carbon number what? On carbon number 2. And then we have another substituent. We have the methyl group on carbon number 4, so the name of this compound would be 4-methyl hexane 2-ol. Identify by name or formula a suitable reagent for step 1. What is happening in step 1? In step 1, we're changing the OH to Cl. In order to change the alcohol to a chloroalkane, I react it with PCl5. Give the mechanism for reaction in step 2. Where is step 2? That is step 2. Give the mechanism for this reaction. Now, what is happening here? Where this is substitution reaction, nucleophilic substitution, where removing the Cl and putting an NH2 instead of it. What is the mechanism for this kind of reaction? The ammonia has lone pair of electrons. The CCl bond has slightly positive on the carbon and slightly negative on the chlorine. So the ammonia, lone pair of electrons from the ammonia, will attack the slightly positive carbon, and the electrons in the bond will go to the slightly negative Cl. That attaches the NH3, but that means that the nitrogen is a positive charge because it is bonded to 4. It has 4 bonds coming out of it. So one of these hydrogens, the bond breaks and the electrons go to the N+. So I end up with the amine group attached to the alkene. DMAA is only slightly soluble in water, but it dissolves readily in hydrochloric acid to form an aqueous solution. And he's saying, explain the type of bonding that occurs between the nitrogen atom and the H+ ion when the positive ion forms. So what is happening here? We have an amine group, NH2, and it is reacting with H+. Remember, this is the kind of reaction in which we have a dative covalent bond, because the lone pair on the nitrogen will be used to form a bond with the H+ ion that has no electron on it. Remember, this kind of bond is called a dative covalent bond. Okay, complete the diagrams to show how the ions formed in the reaction between this and hydrochloric acid interact with water molecules. Remember, here we have positive and negative ions. We're going to surround them by the water molecules. Remember that the water has 2 ends. It has the oxygen end, which is slightly negative, and it has the 2 hydrogens, which are slightly positive. So if it is surrounding the positive ion, it is the slightly negative oxygen that will be attracted towards it. Or if we're surrounding the negative ion, then it is the slightly positive end of the water that surrounds the negative ion. A test to confirm presence of an aqueous solution is adding a small amount of solid sodium carbonate to the solution. So he has an acid. He wants to do a test for the presence of acid by adding sodium carbonate. If I add sodium carbonate to an acid, describe the 2 observations you would see. Of course, you're adding carbonate to an acid. The solid will dissolve and it forms carbon dioxide gas, so bubbles of gas are formed. Sodium ethanoate is a component of reusable hand warmers. In use, a supersaturated solution of sodium ethanoate recrystallizes to form solid hydrated sodium ethanoate, releasing energy. A hand warmer has a mass of 63.2 grams and it forms 20.1 gram of hydrated sodium ethanoate, which is the product in that reaction. Calculate the maximum temperature reached by the hand warmer if its initial temperature is 5 degrees Celsius. Now, what does he give me? He gives the delta H for that reaction. He gives the specific heat capacity of the hand warmer. So that is the C in MC delta T. And he wants to calculate the maximum temperature. And that means that I can use delta H to get Q, and then I can use Q to get the difference in temperature, which is delta T, so we can determine the final temperature. So in order to do that, the first thing we do is get the number of moles. What does he say we have? He says we have 20.1 gram of the product. So I get the number of moles of that, 20.1 over the MR. You should be able to calculate the MR of the hydrated. That means you add up all the masses of everything, CH3, COO, Na, 3 water. You add it all up, it comes out to be 136. So the number of moles is 0.1478. That is the number of moles of the hydrated sodium ethanoate. Now he's asking about what? He's asking about the hand warmer, which is the sodium ethanoate. But what are we going to do now? We're going to use delta H to get Q. So Q is number of moles times delta H. The number of moles we calculated times the delta H he gives me. Remember, in Q, you don't need the sign. The delta H must have a sign. Q, you don't need the sign for anything. So Q that comes out, the delta H was in kilojoules, so I multiply that by 1,000, I get the Q in joules. Now you should know that Q is MC delta T. Now, the hand warmer has a mass of 63.2. The specific heat capacity is 3. So the C here is 3. Times delta T, I can use that to get what is delta T. So the delta T would be 15.4 degrees Celsius. That is the difference in temperature. So if the initial is 5, then the final is what? Then the final is 20.4 degrees Celsius. Are we following? Okay. Then the next question says ammonium ethanoate is used to control the pH of foods. It can be formed by the reaction of pure ethanoic acid with ammonium carbonate. And he wants to calculate the standard enthalpy change for this reaction by completing the Hess's cycle and using the data shown. So first of all, what are the data that he gives me? These are the delta H of formation of all of these things. Now, where is the equation that he's looking for? Remember, he's saying he wants to react the ethanoic acid plus the ammonium carbonate in order to get ammonium ethanoate. But that will give me, because this is acid plus carbonate, that will give the ammonium ethanoate plus water plus CO2. So that is the reaction on top. But then you can use this information that he gives you in the table. So you need delta H of formation of each of these compounds. So the arrows go up. Remember the delta H of formation, I have the elements at the bottom and the arrows will go up. So let us put all the information that he gives me. From this equation, the direction of the arrow is what? Delta H1 plus delta H2 is equal to delta H3, right? Follow the direction of the arrow. So from that, I can put in the information that he gives me. I have delta H1. Delta H1 is, remember that the values that he gives you in the table are for 1 mole. So if we're trying to make 2 moles of CH3COOH, you have to multiply that number by 2. plus I'm trying to make 1 mole of ammonium carbonate, so I put that number, plus the delta H2 which we're looking for is equal to the other side. The other side is formation of 2 moles of ammonium ethanoate, so that is 2 times that number from the table, plus formation of 1 mole of water and formation of 1 mole of CO2. And solving for delta H, we get that delta H that we're looking for is plus 57 kilojoule per mole. Ammonium carbonate is an ingredient in cleaning solutions for camera lenses. These are aqueous solutions which contain no more than 1.8 gram of ammonium carbonate in 100 centimeter cubed. Calculate the concentration of this solution. He wants the concentration in mole per decimeter cubed of this solution. So that means I need to get the number of moles first. The number of moles is mass over the molecular mass. I calculated the molecular mass to be 96, and that means the number of moles is the mass he gives me over the 96. That gives me the number of moles. He wants concentration. How do we get concentration? Concentration is number of moles over volume. So it's the number of moles that we have over, he has a volume of 100 centimeter cubed. Remember, we need to divide it by 1,000 before we put it into the equation. So that gives me the concentration in mole per decimeter cubed. Okay, section C, the question says potassium chlorate is a crystalline solid used in fireworks. It is produced by this process. Stage 1 says chlorine gas is passed through hot calcium hydroxide solution. It forms the calcium chlorate. Stage 2, he reacted potassium chloride with that solution to form potassium chlorate. The solution is heated to reduce its volume, allowed to crystallize, crystals are filtered off, and the remaining filtrate is evaporated further to obtain more crystals. And the first question says, write the overall equation for the Liebig process. Remember that the overall equation is the total of the equations for stage 1 and stage 2. So what do we have? These are stage 1 and stage 2. How do we add them to get an overall reaction? Remember, whatever is the same on both sides of the arrow is cancelled. So there is calcium chlorate on both sides of the arrow, that cancels. And then we add up any numbers that we have on the same side. So we have 6 moles of calcium hydroxide plus 6 Cl2 plus 2 KCl. That's everything before the arrow. Now what do we have after the arrow? 2 KClO3 plus we have 5 calcium chloride plus another calcium chloride in that other equation below. So that is a total of 6 calcium chloride plus 6 water. Now, basically, you can leave it like this, but actually, if you look at the ratios, you can find that these ratios, all of them, can be simplified. 6, 6, 2, 2, 6, 6. I can divide all through by 2 to get the simplest ratio between the reactants and the products. Okay? Calculate the overall atom economy by mass for the production of this product. Now, what was the equation? This was the overall equation that we just got, and he wants the atom economy. How do we calculate the percent atom economy? Remember that it is the MR of the required product. So my product I'm looking for is the KClO3. I calculate its MR. And the atom economy is the MR of what I want over the total MR of all the products. So the total MR of all the products is the MR of the KClO3 plus 3 times the MRs of the other products, 3 calcium chloride plus 3 water. All of this is the total MR of the product, and my percent atom economy is the MR of the KClO3 over the MR of all the products times 100, so that comes out to be 24.04%. Explain the type of reaction that takes place in stage 1 using oxidation numbers. Now, once he's talking about oxidation numbers, then probably you would have oxidation, reduction, or disproportionation reaction. So we have, let's take a look at the oxidation numbers of the chlorine. Cl2, oxidation number 0. Oxidation number of chlorine in calcium chloride is -1. If we look at the calcium chlorate, you should know how to calculate the oxidation number of chlorine in calcium chlorate. Calcium is in group 2, so it will have oxidation number +2. And then I have 2 chlorines. So we say 2x. Minus, we have each oxygen is -2, and I have 6 of them. 2 times 3, so that is -12. Calculate for x, you get that the oxidation number for chlorine in that compound is +5. Now, what has happened to the numbers? The chlorine has changed from 0 to +5, and that is oxidation. It has also changed from 0 to -1, and that is reduction. So this is called a disproportionation reaction, and you have to explain to him, why are you saying it's disproportionation reaction? Because the same element, which is chlorine, has been both oxidized and reduced in the same reaction. The crystals of potassium chlorate formed also contain some halide ion impurities. Describe a chemical test on a solution of these crystals to confirm that the impurities present are chloride ions rather than bromide ions. Remember, what was the test for chloride and bromide? We said we add silver nitrate solution and dilute nitric acid. You should know that the chloride gives white and the bromide gives cream precipitate. And these colors are very similar to each other. In order to distinguish whether it is white or cream, we add dilute aqueous ammonia. Now, the precipitate from the chloride would dissolve in dilute aqueous ammonia. The one in bromide would not dissolve in dilute aqueous ammonia. It will dissolve only in concentrated ammonia. 1.52 grams of impure potassium chlorate formed in the Liebig process was heated until the mass of solid remaining was constant at 1.02 grams. Notice the 1.52 grams of potassium chlorate is impure potassium chlorate. That means we originally had impure solid in it. Now, he heated it until it became 1.02 grams, but he says the impurities did not decompose on heating. So actually, the 1.02 grams of solid remaining at the end is not KCl alone, it is KCl and impurities. And he's trying to calculate the percentage purity of the sample. Remember, if we say that it has impurities, and at the end the solid left was 0.02 grams, that means 1.02 grams is the mass of the KCl and the impurity. So I cannot use that for calculation. So what I need to use is find out the mass of the oxygen. Remember that the total mass of reactants is equal to the total mass of products. So the mass of oxygen is the difference between 1.52 and 1.02. So I have oxygen is 0.5 grams. And this is what I will use to calculate number of moles of the KClO3. So number of moles of oxygen is the mass over the molecular mass. That gives me a number of moles. And then I look at the equation, relate the number of moles of oxygen to the number of moles of KClO3. You can see that 2 of KClO3 gives 3 of oxygen. So these number of moles of oxygen that we have, if I use it to get the KClO3, I have to multiply it by 2/3 to get the number of moles of potassium chlorate. And that means I can get the mass, number of moles times mR, and that means that I originally had 1.28 grams of KClO3. How do we calculate percent purity? It is the mass we calculated over the original total mass of the impure substance times 100. So we find that it was 84% pure. In fireworks, potassium chlorate decomposes. This thermal decomposition takes place in 2 stages with a solid catalyst. Give the systematic name of KClO4. What do you think would be? The KClO3 is potassium chlorate. The KClO4 has the chlorine with -7, so its systematic name is potassium chlorate 7. So instead of potassium chlorate 5, which is the KClO3, it is potassium chlorate 7 because the chlorine now has an oxidation number of -7. Okay, a student investigated the role of the catalyst in this reaction. Heat a sample of potassium chlorate in a test tube with a known mass of insoluble catalyst until the mass remains constant. Mix the contents of the test tube with water. Filter the mixture, rinse, dry, measure the mass. Explain how each of the steps in this procedure is needed to show that the catalyst is not used up in this reaction. Okay, let's take a look. We're trying to show that the catalyst was not used up. For each step, what is happening? In step 1, he says heat a sample of potassium chlorate in a test tube with a known mass of insoluble catalyst until the mass remains constant. Why are we doing that? To make sure that all the potassium chlorate decomposes. Then step 2 says mix the contents with water. This is because I want the KCl to dissolve and the solid that remains is the catalyst. Then step 3 says filter the mixture and rinse with water. Of course, we're filtering it so that we can get the catalyst as a residue, and we rinse it to remove any remains of KCl that is still with the catalyst. Then step 4 says dry the remaining solid to get rid of any water so that it doesn't add to the mass of the catalyst. Then we say measure the mass. We want to show that if it is a catalyst, then the mass at the end would be the same as the mass at the beginning of the experiment. Then he has what we call the Maxwell-Boltzmann distribution curve, and he says explain using the diagram how a catalyst speeds up a chemical reaction. Remember, we said if we're talking about a catalyst, then what is happening is the catalyst lowers the energy of activation. So now we have more molecules with energy higher than energy of activation. Remember that it's the molecules that have energy higher than energy of activation that can collide and have effective collisions that lead to reactions. So what the catalyst does is that it provides an alternative pathway with lower activation energy. So now more molecules have energy higher than the activation energy and more collisions are successful. So that's the end of the paper. I hope you were able to get all the answers correct. And I hope this was useful to you in your revision. Thank you for listening.